afternoon, good evening, whatever the case may be. We are back and better than ever. Today we are going to be able to find a quadratic from its graph. That is, we will be able to look at one of these graphs and write the equation that goes with it. Let's get to it, shall we? That's no good. Here we go. Find the equation of the quadratic function with the graph. All right, so let's take a look here. We got part A here. And what do we know about this? Well, we know we have an x-intercept at -1. We have an x-intercept at 3. So those are my roots. Those are the solutions to this. So if I were to write my solutions, I would have x equals -1 and x equals 3. And I also have a y-intercept right here of 0, 3. Okay. We are eventually going to be in the form y equals ax squared plus bx plus c. And we should know, or should recognize just by looking at the graph, that a is going to be less than 0. A is going to be negative because the parabola is opening down. So, since we know the intercepts, we know our roots, we're going to take a look at this in this manner. Bear with me here. So in order to get a solution of -1, I love me some clarity. Okay, so our factors, in order to get a -1, this is going to have to be x plus 1, and in order to get a positive 3, this would start out as x minus 3. Why is that? ZPP, yeah, you know me. If I set one of my factors equal to 0, I get the root -1. Same idea with 3 here. Now the problem is I don't know what A is. It could be 1, but I'm not sure. But what I am sure of is I know a point other than the x-intercept. You can't use the x-intercept because it's going to turn out to be 0. So you need another point on the parabola, which we have. And on this parabola, when and in this equation, when x equals 0, y is equal to 3. So I'm just going to replace this y with 3, and I get a times, and I replace the x with 0. 0 plus 1 times 0 minus 3. You don't have to do this every time. I'm just showing the steps here. Because you know that 0 plus 1 is 1, so 3 equals a times 1 times -3. 3 equals -3a. A is equal to -1. So that means I can replace a with -1, okay? And so y will equal -1 times x plus 1 times x minus 3. And we could expand it if they ask us to, but they don't. This is perfectly legit answer. That is the equation that, when graphed, gives us this parabola. Let's try this one. Okay. So, it touches once, so we have a double root. Again, we're going to have y equals a times x. It's going to be opposite of +2. Minus 2, and since it's a double root, I can just put squared. I suppose you could put another x minus 2, but the more efficient way is to write it as x minus 2 squared. We have the point 0, 8, so we can figure out what a is equal to. Replacing y with 8 equals, that's a horrible 8. We're going to have to deal with it. A times 0 minus 2 is -2 squared. 8 equals -2 squared is 4 times a is 4a. So a is equal to 2. We knew it should turn out positive because it's opening upward. So that means that y is equal to 2 times x minus 2, the quantity squared. Alrighty, so let's try another one. Find the equation of the quadratic with this graph. Alright, so we have, let's see, we have an x-intercept here. We do not know what this is. but we do know what the axis of symmetry is, right? So I'm going to start off again with y is equal to a times x, and since this is a negative 2 right here, this factor is going to be x plus 2, and then we have x, and we know we have a positive x-intercept, we just don't know what it is, but that means this is going to be minus, and now we need to find out what this is going to be. Okay, so how do we do that? Oh snap, we have an axis of symmetry, and the x-intercepts are equidistant, the same distance from the axis of symmetry. I know this point is 1, 0, right? So it is 3 units away. In other words, to get to negative 2 from 1, I would have to travel 3 units to the left, which means this point, this other x-intercept, must be 3 to the right of the axis of symmetry, giving me 4, 0. Booyah, I have x minus 4. I also know a y-intercept here of 0, 16. So when y equals 16, my a equals 0. I skipped ahead to the answer there. So 16 equals negative 8a. A is equal to negative 2. So I know the equation of this particular quadratic is going to be negative 2, which it should be. It's opening downward, times x plus 2 times x minus 4. Giddy up. Moving on. Okay. Find the equation of the quadratic whose graph cuts the x-axis at 4, negative 3. So maybe we want to do a quick sketch. 4, bam, negative 3, bam, and which passes through the point 2, negative 20. So 1, 2, and I don't know, negative 20, maybe way down here. Okay, so it passes through this point. Okay, give your answer in the form y equals ax squared plus bx plus c. Okay, so we know that, okay, and I'm going to label this point 2, negative 20. And we should be able to tell whether or not this parabola opens upwards or downwards. The only way it's going to go through this point is if it looks something like this. Ooh, that's not too good, but you get the picture. And so, again, we're just going to have y equals a times x. This is going to be, since I have a root of negative 3, this will be plus 3. Because this is positive 4, x minus 4, and I know I have another point on the graph, so this is negative 20. I can easily solve for a here. So x is 2, 2 plus 3 is 5, 5 minus 4 is 1, so I have 5a equals negative 20. A is equal to, wait a second, I've done something wrong. What did I do? Why did I put 4 there? I'm an idiot. Okay, sorry. This is 5 times negative 2. So negative 20 equals negative 10a, and a is equal to 2. But I caught myself because I saw I was going to get a negative, and I knew that it had to open upwards, so that makes sense. So now I have y equals, replacing a with 2, 2 times x plus 3, times x minus 4, and I'm gonna I have to put it in this form. So all I have to do is expand this. Y equals 2 times expanding or taking x plus 3 times x minus 4, it becomes x squared minus x minus 12, distributing the 2, y equals 2x squared minus 2x minus 24. Booyah! All right, only one more example for you, and we'll wrap this up. Find the equation of each quadratic function given its graph. Okay, boys and girls, we know the vertex. Yeah! So that means, this is actually, I think, the easiest. We can put this in vertex form, which is y is equal to a times x minus h, the quantity squared, plus k, And remember, that is where the vertex has the coordinates h, k. All right, so what can we do? Well, we replace h with the x coordinate of the vertex and k with the y coordinate. So that would give me y equals a times x minus 3 squared, and k is -2, so minus 2. And I have the y-intercept, so I have the point 0, 16. And you know the story from here. 16 equals a. X is 0. 0 minus 3 is -3. -3 squared is 9. Minus 2. 18 equals 9a. So a equals 2. Meaning that the equation of this quadratic, which when graph gives me this parabola, is y equals 2 times x minus 3, the quantity squared, minus 2. Done. Done, 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 done. And this is positive. It opens upwards, so things check out. Here, vertex of -4, 2. I have an x-intercept of, let's see, -2, 0. Actually, I could also, since this is at -4, this x-coordinate, I also know that this is -6. But we're going to go ahead and use vertex form. Let me get rid of that as not to confuse us. Because we've already done that. So this is just another tool in your toolbox. Y equals a times x minus h, the quantity squared, plus k. So y is equal to a times, vertex is -4, x minus a -4 is x plus 4, the quantity squared, and k is 2. I have the point -2, 0, so go ahead and solve. I know that when y equals 0, x is equal to -2. -2 plus 4 is 2, and 2 squared is 4, plus 2. Subtracting 2, -2 equals 4a. So a is equal to -1/2. I expected a negative since it opens downward. And then for this, I just replace, I replace the a with -1/2. So y is equal to -1/2 times x plus 4, the quantity squared, plus 2. And there you have it. That is a wrap for this content. I hope that you enjoyed it. I know that I did. And let's get some clarity to bring this out or to wrap it up. And we are out.